All right, so to do this problem, we're going to break it down into two different triangles. So there's this triangle here, right? So I've got that triangle in yellow, and then probably we'll do this pink triangle here, right? And then the other key thing is you got to remember your parallel line theorems, right? If you got two parallel lines, which these lines would make parallel sets of lines, you get the angle relationships there. So for example, like alternate interior angles, this angle would be equal to that angle. This angle, vertically opposite angles are equal, but these are alternate interior angles. And that actually is what we get here. So if that angle there is 49, because this line here is the transversal, this angle right there would also be 49 degrees. Okay, so that for the for the yellow triangle, that angle is 49 degrees. And then for this purple one, that one's going to be 63 degrees. Okay, so this angle coming out here would be 63 degrees. All right, so what I'm going to do to get this, I'm going to use this 145 and trig, and I'm going to get the height from here to there using the 49 degrees and the 145 side there on the bottom. And then for the purple one, I'll get the distance from here to there using the 63 degree angle, and then I'll be able to subtract them to be able to get that distance there. So because that was the question, it says show that the vertical distance between the rooftop and the apartment is that. Okay, so it's not asking us to find a value, it just wants us to show that that's the equation that it would equal. Okay, so the way I'm going to set it up is I'm going to use the 49 degrees, get that length there first, and then I'm going to use the 63 degrees to get the whole height of the building, and then I'll just subtract the two to get just the height from the apartment to the rooftop. All right, so let's do the 49 degree one first. So that would be, we know the adjacent side, we're trying to find the opposite side. So that would be tan. So the tan of 49 degrees would equal, we'll call that y. So that would be y over 145, opposite over adjacent. Okay, so that means that y equals the tangent of 49 degrees times 145. Okay, so now I'm looking at the purple one. So now I want to get, using this big triangle there, same ratio. I have now that angle there is 63 degrees because it's alternate interior to that angle. So we'll call that one, we'll call it, say, x. So that would mean that the tangent of 63 would equal x over, sorry, not x over, yes, x, opposite over adjacent, 145. So x would be 145 times the tangent of 63, right? So if this would mean that d would be equal to, right, to get, if that's d, it would have to be x minus y, right? The whole height there is x, and then if I subtract y, which is this bit, that just leaves you that part left, and that's what we're trying to find. So I have the x there, I've got my y there, so let's just subtract them. So that means the distance is going to be the x, which is 145, tangent of 63, minus 145 times the tangent of 43 degrees. Sorry, 49 degrees. All right, we want it to look like that, but notice there's 145 being multiplied on both of those, so I can factor out the 145, and that would be the tangent of 63 degrees minus the tangent of 49 degrees. And there, I have shown now that that's how I can get that distance.